SI. Okay, you will find there 2 Excel files. So we will work with this. So the description of this data is, this is a maze data with 78 parents, parent 1 and 11 parent 2, 5 checks and 211 hybrids. We have 18 environments, and did you remember we have this all of variables? Okay. Okay. In the file, you will find only the variables that have 1 in this table. That is the variables that are important for this study. Okay. If you remember, these signs refer to if we want to increase or decrease the behavior. Okay. So based on this, we will work to know how to do selection index in Bioflow. But for that, first of all, we need to do first step. Did you remember what is the first step?
The which? Analyze the data.
Analyze the data. Okay. So we will start with, what is the first step for analyze the data?
Quality
control. Okay. The second step? Single trial analysis. And the last one?
Multi-trial analysis.
Okay. So please open your Bioflow, obtain the files that I share with you in the day 7.
Which one is the information? Data 7.1 or 7.
In folder 7 there are a folder SI, and there you will find only 2 files. Okay.
Parent and some.
Yes. Okay. So here, this one is the raw data about this study. And this one is the relationship about parents. Hybrid, parent 1, parent 2, and other name for hybrid. Okay. So we need to use both files in Bioflow for start to do the analysis. So please, by a team, if you prefer, by line of tables, start to do this analysis. I will give you more or less 15 minutes for start, and then we will do it step by step. But the idea is that the first step, try to do by yourself, please.
My Bioflow is not still working.
No?
Can we use parental file or SI example?
You need to use both files. This one is the raw data, and the other one is the pedigree data. Okay? So at the start, we need to upload our information. So remember, we need to go to data management and retrieve new data. So remember that for each one of the information that we have, we need to upload in each one of these folders. Okay? Yes. So the phenotypic information is this file SI example, okay? This is our phenotypic information. So we need to upload. And now we have all the information here. So for match the columns, we need to know which variables need to put in each one of the fields, okay? So in this occasion, trial and environment is the environment label. So we need to put both. Replication and block are the variables for experimental design. Range and long row is row and column. So we can do it on a spatial analysis. Entry type is the variable that we can use for see if it's a check or a line or a hybrid in this case. Then we can see two columns for label the hybrids. One is with a entry name and the other one is with another name, okay? Both are useful for do the analysis. You can decide which use. And then the labels for parents. And since grain yield up to the end is the variables that we need to use, okay? This time I put all the variables that have one in the table for be easy to use, okay? So we need to include all the variables. So go to the match columns and select in location, select environment. In iBlock, select block. In column, select range. In designation, we can select, we can select hybrid. In trait, we will select all the traits. Okay? Okay. And then when we need to define the environment, appears location and trial. That is that we need for do this. So compute environment column. Okay. And now our status is data complete. Okay. Until here, you have doubts. Everything is clear, right?
Yes.
Okay. Now, for pedigree information, we need to upload the other file, parent file. Okay. Here we have only 4 columns: hybrid, parent 1, parent 2, and the other hybrid. So in the phenotypic information, I use hybrid column. So we need to select the same, okay? So in designation, hybrid, in mother, parent 1, and in father, parent 2. This time we don't have information about year of origin, so we can put nothing, okay? And check the status. Now data is complete. All is fine until here?
Yes.
Can you go back to genotypic? Genotypic.
In genotypic data, it's not possible to upload nothing because we don't have information about genotypic data. We have only phenotypic and pedigree data. Okay? For that reason, we will use only these two information. Okay? Okay. So the first step is to do the quality control. Okay? So the way to do this is to select all the traits.
Phenotypic quality control.
Yes.
Yes.
No need to save that. Okay, safety.
Yeah. Okay. I will select all the traits because we need to see trait by trait and see the behavior for decide if we will put the same coefficient for all the variables or we need to put different coefficient for the variables. Okay. So at the start we need to see a grain yield. So for the grain yield with this 3.2, we can see that maybe this one and this one value are not captured. Okay, and maybe this one is outlier and also this one. So we need to keep in mind these points for decrease the values, okay, in the coefficient. So yes,
Are you running or have you run all?
you can run at the same time
Okay.
or one by one.
Okay. But you are doing one by.
This depends of which coefficient you decide to use for each one of the variables.
Okay.
If you decide to use the same coefficient for all variables, so select all and put the same coefficient.
Okay.
But this is not useful in many of cases because you have different variables and the behavior of these variables is different.
Yeah.
So you need to be careful. I select all only for see all the behaviors and then decide, okay? So this is for the order variable in each one of the environment. If you see this variable is only a variable in this environment, but not in others. So this is another way to see what information I have in each environment. Okay. The other is the same. We have only this information of variable is in these environments, but not in others. Okay. Moisture is in all the environments. pH is missing in 3 environments. This one is missing in 9 environments. We have only this information for 6 environments. And this one only for 3 environments. So at the start, we can see the behavior of each variable. So it is fine for all of you, all these variables. Look at the variables, please. And tell me which variable is useful and which variable is not useful, please, for the analysis.
I still have some challenges. Getting the traits uploaded.
Yeah, it is a process.
This is what is that?
And very few outliers also. Only one I can see. The root lodging or what?
This one is what MOU.
MOU is not a moisture. Don't know where to put more. Cannot put
Franchise or
PSA Limited. Sorry. DH name was EWT. It's very difficult to decide. But then we see that you cannot use. Yeah, but sometimes it's some kind count data is counting
This one shakes. Terrible.
Yeah, it is amazing.
Maybe. If you can see this one. This one is.
That's wrong. We have needed most of the location of
The pH of the book.
the text.
it's not
The page of accepted.
It is.
which above is a listed trade.
This one.
Accepted. Renewed moisture and franchise.
Trade.
Listed trade.
Mm.
Only one this one.
By
It's 1, 2, 3, 4,
So many environments.
7, 8, 9 over
trades. Which one is more?
because we are using mean for the
If the trade
it's a mean. If the quality is good.
environment, we have to
Huh?
You can choose it.
Definition is what?
Destination.
Destination for the there's an hybrid. Yeah, that's what it is. Row is the range. Row is the range, not long.
Which one is?
Well, the row is the range.
Okay, so which variable? Which variable we need to include and which not? Which of
Ones to include granular moisture and franchise.
Trata de copiar la carpeta del Bioflow, darle diseño directo en el texto, porque lo tiene adentro de una carpeta de otra carpeta de otra carpeta, y entonces no puede leer. Yes. Okay, so red meal is good or not?
Yes.
Good.
Yes.
Yeah. Okay, now PRL is good or not?
No.
Why?
environment.
The problem is not only the environment, but the quality.
Yes, exactly. Because we don't have variation.
Variations.
So since start, we can see that this variable maybe is not useful for our analysis.
Yeah.
Okay?
But my question,
Yes.
most what's it called? Selections. Which lodging is an important? A must have.
Because in this case,
It's a good to.
Good to have. Good to have.
Still whether it is analyzed or not, it just bring any significance.
It is in theory, but the data we have here, it cannot be used to select a parent. Yeah.
yes.
But there's also this issue of the IQR coefficient. How do we handle?
Just
No, this is because all of the information don't have a lot of variability, and if we put this threshold, well, we obtain many outliers. But if you select only this variable and trait independent, on in the when you try to run the single trial analysis, you will see the editabilities and the other things. So in that case, it's the same. The editability in many of these one, we will see at 0 because we don't have many variants.
Angela,
Yes.
the main issue is to say, how do we then adjust the coefficient relative to a given trait?
Yes.
So you analyze them separately, and this one you set it very high.
Yes.
So we can't throw it away if we have one standard coefficient. Unless you
No,
choose.
for all.
I'll try. Yeah.
But for that reason, the idea is to see by one and decide to put the same or put another different QC for other variables. Okay?
This is a good example of why you need to
Yes.
use a different IQR for a different
Yes.
trait.
Exactly.
Because on yield it worked perfectly fine. We looked at that, but here you can see it's a problem because the trait is bounded by 0, and most of the values are 0.
Yes.
So anything like a disease or logic, anything percentage-ish, is going to have this problem. So you need to use a broker. Try to do more.
Yes.
What will happen if we transform this data? It's also logical. What will happen if we
Transform?
Is the system busy or more thinking about it than
It can transform.
Yes, it's an option, but the problem is not the value 0. The problem is that you don't have a lot of value.
But can we use
different options for different traits? If you have more than one position, you can make it.
Yeah, I will show you.
You can get the different information because we need the block.
Okay.
Yeah, we can move the.
Now for this one, for this variable, you will use the same coefficient or you will change?
You can change it.
Yes.
Yeah.
different.
For this one,
Okay. It's okay.
okay. For this one,
Yes.
Can you just go back a sec?
Moisture.
Moisture, yes.
Moisture,
The moisture.
one location.
You know, I think most of you have been picking up that there's a
That location. we can-
strange phenomenon going on there
Yeah.
in the 6th one from the left.
Yes.
Yeah.
You mean that we can drop that location from the maybe.
You can look at, it depends. If you look at the data,
Okay.
basically, most of the values, a large number of the values are like 15.9 something.
Yeah.
So you have to decide Did something go wrong in that trial?
Yeah, look, this data is for maize, right? So for maize, this is 15. We saw the 15 is not bad. Yes.
17 maybe because
Yeah, it is like 15 point something.
Yeah, it's 15.9.
So 12.5 is the ideal. So we can still go up to 15, 16.
But the question is, when you look at this, if I look at this, the first thing I'm going to say is it's something that messed up with the measurements because they're all the same. Well, most of them are the same. So whether you keep the data or not this is telling you to have a look at the data again.
Yeah, all the measurements.
And say, did somebody mess up the measurements here? Did somebody paste down in Excel 15.93 by accident? What you need, this would be a case you go and investigate.
These are hybrids, different hybrids. So this particular ones with certain hybrids, which you know the rate they dry down is made fair. Somehow the hybrids dry down just harvesting time.
Just stand on
This one, it happens in actual life. That is what I know.
So that you
Especially with the materials.
those become like
and also the rates they dry down. The maturity time, like 5 days of maturity time can give you this 15.
What have you done?
I don't know.
Yeah, it gives you all the same.
Exactly.
But then you ask the question, is that the best way to,
even the
is that an artifact or is that
it is
But
because of the way you
when you use that formula to calculate for yield, you know there is not such significant difference when between 15 and 13 moisture. When you put those into that yield formula, threshold 80% something with all those things, and then there will be very insignificant difference between the yield.
Yes.
but you have to make a decision whether to remove those outliers.
Yeah.
And to me, they're not outliers. They're the
They
same.
are not outliers. That is what
Something like you said, if it was a late drying or something that makes everybody have exactly the same moisture.
Yes.
And you can explain that, then you say, well, I've explained it, that's good, but I'll keep those other values. I won't remove them as outliers.
I would have kept that.
Maybe just an idea that maybe to write further.
But you know the majority. The majorities are 12, 11. Then in maize you go less than 12.5. It's not good. You know, you are getting wrong yield information.
Yeah.
So if you keep them to dry this one up to 12.5, the others will go down to 8.
Okay. But is it possible to pick those those entries that are showing high level of moisture and write them separately to lower the?
It is okay. 15 is okay. 15 is no problem.
It is
That is
okay
why.
because they give the calculation adjust.
Because normally what I know is
12.5.
we normally use the moisture content to adjust the yield.
Yes,
It's not a parameter that we normally directly analyze.
Yes.
Yeah.
it is you will adjust
Yeah.
the yield.
But there's only you only need this data to calculate for you.
Yeah.
The moisture
And then you
data.
adjust it.
So you-
Yeah.
Exactly.
Yeah, maybe the problem is that it's that location that we are observing this. Otherwise, if it's linked to the trades, we may see something across the location.
You're
Then
right.
the fact that it's one location, that's why we need to look at what happened and know that how they measure it and yes, you see that one. Yeah.
What is, two things to consider. One, this data, even if it is there are several outliers, the outliers are still in the acceptable range for maize. Number one. Number two, moisture content is not a parameter that we normally directly analyze. Yes, we used to just
yield.
when we are converting the gradient to kg per hectare or ton per hectare, we use it to adjust the yield. So it's not a parameter that we directly analyze. So because of this, I don't think we have
maybe even the traits we don't need to use.
Yes, because the adjustment by itself will take care of this outliers because they are just simply important to adjust the yield. They are not a parameter by themselves. Not a standalone parameter.
Okay, good. That's fine. Otherwise, that one, maybe the guys sample all of them and put in the oven, dry it at the same level, try to measure some few of them give like half left. It's a lot of things can happen that can show this, but as you were saying, maybe the trait itself is not useful for that kind of analysis unless it is used associated with the yield adjust other traits. Yeah.
We don't even consider this as
that's
a problem when we use data for maize 15, 16, 12, 11, we are fine.
Yeah.
Once if it shoots up to 20, now you have to consider. Otherwise, this is a perfect data. No issue. 15 is fine.
Yes. Only to see why, for what reason you have a lot of the same.
That particular location.
Yes, in that particular
Yeah.
location. Yes. So this one, yes, plant height. Only we don't have information in 3 environments. We have lost.
Yeah.
Okay.
It's okay. Yeah. Even this one.
This one is the same.
You
We
say-
have many
Missing
environment
Yeah.
in this rate.
Yeah. But it is okay.
It's okay.
Who would keep those outliers?
Yeah, we
Would you keep those or remove them?
Yeah. Otherwise, the number of locations available, I think that we can analyze and use. We just solve the problem of outlier.
But this one is an outlier or not?
They can be.
What do you think on this one?
I will keep them.
Yeah, I think I'd keep them as well.
Yeah.
Partly because again, it's another trait that has a zero boundary,
Yes.
so it's not.
Actually. Lots of missing locations, but it is good.
Yeah.
Okay. Now, who would remove the outliers here?
Yeah.
The speed. What
This
is
one
it?
will also take into.
Yeah, the outlier.
Is it 1,000 seed weight?
1,000 weight.
Is
I
it
think
what
it's
the
about
TWT?
It's
1,000,
test weight in grams, but I don't
100 or 1,000?
know if it's
Test
100 or
weight.
1,000.
Yeah, it's very
Test
important.
weight. in maize,
It's very important.
Yeah, in maize we call it field weight. You measure the crops in the field.
Yes.
If it is test weight, is
Okay.
but we do test weight. If it is 1,000 seed weight, it is in gram. But test weight is in kg. But you cannot get that up to 80. We have seen the raw data.
Yes.
But
So
the
that
field
means
weights
this
are-
is like a
is the
seed weight.
maximum. It should be the seed.
Seed weight. Since you are now looking at the value 80 around there, can get 80 kg.
No. Field weight, no.
Yeah. So most likely it's seed weight, and it's very important.
This is
Yeah.
seed weight.
It's
It
very,
should
yeah.
be seed weight in gram.
Yeah, it's very
I'm
important.
going to have to go and find one of our maize breeders to find out what these traits actually are.
Yeah, it's very important. So what can we do about it?
So
We
who
keep
would, who would remove
It's important. Yeah, we
who would remove the outliers?
the
And why?
outliers.
Would you remove them?
Maybe affect me?
Yes.
So go back, if you could flip back to the yield.
Can we go back to the data?
No, the yield.
So you see on the yield for those populations,
Yeah, exactly.
there's no outliers.
Mm.
And now go forward to the test weight again.
Onto the test.
So there weren't any outliers in those populations for you,
Only one.
but you have big outliers for test weight.
Yeah.
And those things should be correlated. Therefore, I would say, well, something went wrong with the measurement here. Because it's unlike, if it was real, there should be some low yield as well.
The correlation is also high with grain.
So that's worth thinking about. Maybe I do need to get rid of some of these outliers.
Most of location data is not available there or staged.
Yeah.
Yes, it is.
It's not available. Yes.
But this is the case where you would maybe consider getting rid of
Yeah,
a portion of those out.
Or positive.
They're quite far out and they're unusual.
Yeah.
I mean, you want to see what the values are. Maybe that actually happened. You might want to go back and check with your field team as to whether they actually noticed that. And what it
Last one.
What's this?
Yeah.
Is it?
It's in 3 locations.
Gray spot.
Gray spot.
Yeah, this is good.
It is possible.
It's really
And
spot
that is
is good,
possible
but-
because most of the time it's done in one.
In the
specific sites.
In hotspot area. Hotspot area. Where you have
or
GLS,
on station where you control it.
Yeah.
Like artificial.
Yeah, artificial inoculation. Yes, on station.
That's good.
Yeah, it's good.
Okay, so in this case, now we take a decision. So,
TWT.
TWT remove.
Let's get rid of TWT.
Don't do that.
Assume it is something we needed to do. We're going to keep it in.
Exactly. Should be FWT. That is the standard we know.
No, TWT is good.
Field weight.
Test weight.
We don't really know.
I think that is resolved since we have the
maybe
value
for
in
special
range
project, but student
Which one do you
who
want?
is doing like all the stuff, but the standard one, I never encountered TWT.
The real is already there. What is
Logging from screen. And this is our
But they use it for result calculation, for grainy calculation.
The field weight is if it's per plot, you can extrapolate it.
She removed many of them.
Yes, those are needed for extrapolating the whole yield per hectare. Well, we are interested in the seed weight. Now that's a different parameter. If you have seed weight, you have field weight, those are two different.
But I was
Obviously, this is seed weight.
Mohammed, it is grain weight.
But for some reason they
Okay,
I don't quite know why.
those one.
Well, you have to also identify, is it 100
I mean, they
or
wanted to
1,000, or you don't do that in
They wanted to
Yeah, that's very
It is always 1,000
seed weight. No, but it depends. If you don't have enough seed in the plot and you decide to take 100,
100 seed weight.
100 is multiplied by 10. You
not all you can.
You can transport, so it is very close. Yeah.
But again, when you combine this, how is
In a minute, we do is we put sometimes 100 seeds. We multiply by 10 if you want 1,000 seeds, and it is
You don't
not too much by yeah.
from the greenhouse.
Yeah.
So
No,
when
we
you
don't grow
run
any maize in it.
experiments in the greenhouse, you report per plot. You don't report per hectare. If it is a pot experiment in the greenhouse.
But in
You do
medicine, the import experiment is extremely very low scenario. You just use it.
No, but for wheat.
For wheat, yes. I know. For wheat and rice and other stuff, I know. But for maize, it's completely.
Why
No,
we
you wouldn't do
didn't keep TWT? Yeah, we remove it.
Outside.
Yeah,
yes,
No,
because
what
we
I'm
need to
saying is
delete
sometimes spring,
yeah.
especially under controlled
And so
environment.
for that reason, I keep only this one.
Yeah.
So you will be interested in the yield.
But you remove it from the list.
Yes.
Any.
So yeah, go back again and explain that
Yes.
because everyone was.
Yes.
That was
So,
a critical point.
So now we are
Yes.
separating the.
so now we agree which which outliers we will to remove and which not. So for grain yield, this one is okay.
Yes.
For this one, we need to keep the information. So for that reason, I delete from the list here. Okay. Also for this one. Okay. And for moisture, we need to keep, but we need to increase a lot of the coefficient for keep big values. Okay. So we need to increase a lot.
So for MOI, wow. You move from like 3.2 to almost 100.
So we need to increase like this for keep this information. Okay.
No outline now.
But when you do like that,
Is it the way of removing the outlier?
to all the trees.
No, in this case, we don't need to remove. We want to keep.
Okay.
So for that reason, when we want to keep the information, we need to increase this one for
all of them.
tell to the software that we want to keep all the information. Okay? Don't detect outliers.
Only for that rate.
Yes.
Okay, so you can treat each trait with different coefficient
Yes.
independently.
Yes. Yes, it's possible.
Sometimes this.
When you put that one that would it analyze for the other traits? The now that
That's another
No, yes, for that reason,
just for one.
I explained you which variables we include with which coefficient. So if we want to keep the information in moisture, we need to increase the coefficient until that value. So for that reason, we will put by separate, okay? So remove also from this one, okay?
So you do have the option of removing that type data also in Bioflow.
Yeah, you want to keep it on, okay?
Yeah, I'll just like
Okay. Now,
because
for
don't
plant
need all
head,
the location.
this coefficient is good or not?
It's a representation.
Yes.
That the fact that it is only one location, and for the type of analysis we are doing, we don't obviously need all the locations. Then is it better to remove the location or to increase until 99 to solve the problem? What is the best?
In this case, you might be better removing the location.
Yeah.
Yes.
But we're just, this is the first step of QC and we're showing you some of the options.
Okay.
But in that case, you probably would say, I don't like that location. And then at the next step, I guess, you can remove that whole data set.
Yes.
But in general, this is just, you might look at some data on yield and you see what actually I think probably I do need to change the threshold a bit.
Okay.
I mean, that's an extreme one where you change the threshold a lot. But this is just the first data QC step. You want to get rid of the obvious errors. And in that case, we don't think it was the outliers weren't an obvious error, probably the ones in the middle are probably the error. But for now, just get through this step. We only want to make sure we're removing things we're sure are outliers.
Okay.
So we set the threshold high to get through the step. You have other options. This bit can also be done in EBS. And if you do it through EBS, it will flag, and then you can just keep the ticks or remove the ticks for flagging it as an outlier.
Okay.
But this is mainly an illustration of the first step, and in reality, you're correct. We would probably remove that whole trial data for that trait.
Okay.
Yes.
That's how you would do it. But this, remember, is only the very first QC step where you want to remove any obvious outliers. And so if we weren't decided yet what to do with that population, we make sure we change the threshold so that there aren't any outliers and we remove it at the next step.
Okay.
Okay. So for these 4 traits, we will use this coefficient. Yes, only for this trait. Okay. Remember the traits is grain yield, plant height, and disease. Okay. Okay. So go to run the analysis. Put maybe a name that identify these steps.
Okay.
And tag the outliers.
The 4 traits.
Okay.
Call them the 4 traits.
Please, can't you
Call them the 4 traits.
Yes, only for these 4 traits, we use that coefficients, okay? So now we need to come back for select the other traits and do the QC for the other traits using different coefficients for keep or delete information, depend.
This click the traits drop down and see the
Quality confidence.
The 4 traits.
The 4 traits, 3.2 quality controls.
Do we decide?
All these 4 traits have the same IQ1?
Yeah, can be run.
Same coefficient for these 4.
Yeah.
Okay. Okay. So now go again to input steps in set trace thresholds. And now we need to select another. For example, this one. Okay. What is our decision? Delete or not? Increase the coefficient, right?
Yes. If you increase and those guys are still lying down like this.
Nobody. Nobody. No, that's why. No, but our problem with the trade in the first place is lack of the variability. Is that not what we said? It's not just about the outlier.
For this one,
It's just that there's no variability. So
let's increase.
Yes, well, we can increase or we can delete or check what
I
happens.
thought this is for controlling outlier.
Yes, yes,
So
yes.
even if you increase, will it change?
We'll see whether they will not lie.
We are moving to 200. Increase.
Yes.
There's no variability in the data.
We have just given the program in real life.
Now we can play with
This trait, you'll see the heritability is low and
Other,
it's borderline.
So let's just. You are.
In real life, you probably let it through the QA and then remove
The question here comes when we've not been
We want to be able to select it.
Me, I'm not with you.
Input step.
the coefficient
Mine has
that
freeze.
is stage 1 and the coefficient to use
Input
is stage
step.
2 and coefficient to stage 3. How do you align that?
No, it's relative to the data collected. So it's not about the stage. The quality of the data that you are getting that determines what you're going to do with that information. So it's not about what level, where are we in our evaluation. No.
It's about striking a balance between data quality and how important the trait is in the protocol. So you might have, if you got some crappy yield data and the heritability is 0.3, you might say, well, it's so important as a trait, I'll keep it in. But if your trait is root lodging, and it's not as important as yield, you might say, well, my heritability is 0.2, which it is in this case. Maybe I'll drop it for this year, and next year when we have better data, maybe I could include it in the index. But it's balance. You're making a decision where you're trading off how important the trade is in this year, and actually whether the data we have is good enough quality to make sense of the decision. And in general, so this case we have 8 traits. Remember, 8 is pretty high for you for selection of index.
Yeah.
So if you have a trait that's not very good, and maybe it's not the most important trait, you maybe say, well, we'll do better on the other 7 traits, and we're not going to pursue this 8th trait because it had bad, it's not, the data isn't very good anyway, and it's not the most important trait, so maybe this year we won't do that. That's the kind of decision.
Yeah.
But that's entirely a breeder decision. You lay out the data in front of you, these are heritabilities, I know what my priorities are, and this year, I think I'll make that decision not to include this because we don't have.
Yeah. It can even be sometimes essential traits, good traits on your PPP, but you don't have data this year. You will select with the data you have, maybe, and plan to have data on it, and yes,
Yeah,
and rerun again, and you keep improving the parental line selection.
So
yeah.
Can we decide to remove this MOI?
Moisture.
Moisture?
Yeah.
So you could decide to remove it, but the breeders, when we did this analysis,
We have finished. It has finished its work. We have computed the gradient.
No, that one is not bad.
No,
Yes, but
but still, it will not help in making a decision. We are making a decision. So
It's not, they don't.
yeah, even though the data is good, but it's not going to help us in making decisions.
Yeah.
This is
MOI can go.
okay, yes, we can decide that
It's an exercise.
in the next step. Okay?
Yeah.
No. This is real. This is real life.
It's an exercise.
And this is a good quality data. Only one location.
My
But
share is going.
if the trace itself maybe is not informative or selected, then we can decide.
okay, we'll do a moratorium on maize breeding discussion. We're going to go with the traits that the breeder who requested this analysis that I did told me to put in.
All right.
But yeah, point taken that some of the traits you might have
Did
different.
he say moisture should be included?
Yes.
Oh, wonderful. That's okay. I'm just saying, if it were me, because moisture.
That's sorghum.
No, if I get the yield, I don't need the moisture.
Main guy they said
it's
not
really heritable. It's
I actually don't understand either.
It's not heritable. Moisture is heritable. It's not heritable. It's environmental. You do the drying and then you make your assessment. You have oven. You have natural drying.
Let's read on the exercise.
Guys, so for this other traits, we need to increase the coefficient for taking consideration all the information. So select these traits and put it a high coefficient for include all the information and run the analysis.
Still load captions.
Maybe this one 3 traits. Okay, so we have now another time step for only 3 traits. And the last one that we need to include is...
Sorry, the analysis we run will be the same name of the first file?
Different name. Different name. The first one, I put it 4 traits. This, I put it 3 traits. And finally, for this one...
3 traits. Those are those 3 traits.
No, yeah, 3 traits.
We moisture.
Moisture, PRL, PSL.
All those. But we could say that we increase the moisture separately.
We increase it to 161.
4.2.
For all of them.
For all of them. For the 3. For the 3.
We will go back again to input step.
This one.
Okay, and maybe only for this trait, we will put that coefficient for delete only these values. Okay, the down values. Okay.
Right.
So only this trait with this coefficient and go to run. Yeah.
My 2.7 is still showing outliers.
Yes.
For TWT.
Yes.
It's still showing.
Yes.
No problem.
Yes. We only delete the.
Sorry,
the down.
yeah, for this one, for this one, it's okay.
Yes.
But yeah, but now let's get the others. We keep the same for
Until 100.
for all of them all.
Yes.
100.
Okay. So everything is until here.
22.
Yes. So now we have 3 time stamps. Okay, because we did the QC analysis by separate, by groups of variables, depending on decisions. Okay, yes, everything is clear until here.
Yeah.
So it's possible to do by separate. Okay, it's possible. So now the next step. What is the next step? Single trial analysis. Okay. So go to selection tab and select the single trial analysis. Now, in the input steps, if you open here, appears all the QC analysis that we did before. So, in this case, we need to select all. Okay? Because we want to do the single trial analysis for all the variables. So that's the reason that we need to include all. Yes.
This is a bit late. The one trait, what was the is the moisture?
The TWT.
TWT for one trait. The first one we did, I think I didn't select one trait. If I select these three, would it affect the work?
You just analyze one.
Yes.
It will affect it, so I have to go back and do for only 4 traits.
You can.
I can go ahead.
Yes, you can do it. Okay. What is here is clear that you can select different QC because you have different traits in this QC. Okay. So then it automatically appear all the traits that we have in this QC. We don't have covariables.
It's okay.
Yeah.
We didn't remove that.
Yeah, we did.
And here we can see the dispersion of each variable in the different environments. So it's the behavior for grain yield here in the different environment. And in this case, my information have row and column. For that reason, appear another graph that is a heat map when we can see the values across the field. So here is the columns and the rows. So this is the behavior for this environment and this other and this other and this other for grain yield.
So the red showing low yield and the
yes. Look at
the green is showing a high performance.
yes. Look at the scale. The orange one have small values about grain yield. Yellow one is medium and green one is high. Is more or less the values is more or less between 5 and 10. Okay, so all the values for grain yield is between 5 and 10. So we can see the behavior also across the field. For C patterns in the spatial field.
This is for the grain yield.
Yes, this is for the grain yield. So if you can see in this specific environment, we can see that we lost many information, right? Because we have a lot of missing values or blank values. Also, in that part, we have that also missing values. And here, so since here we can start to see the behavior of each variable.
So this is exactly showing the row column.
Yes.
These are in the field.
Yes.
Okay, good. Can you scroll down? I want to see the trait. Did you select all the traits?
You can see trait by trait.
Trait by trait. Okay.
Yes, for example, in the case of this other.
Okay, but we run with all the trait and we look at trait by trait.
Yes, you can look at trait by trait, not all inside. Okay.
So the blank spaces in the plots, is that the outliers are trimmed out or are the missing values?
Yes. In this case, will be missing values and the outliers.
Good.
Yes.
The view is not displayed here.
Because maybe you don't select at the start the values of long row and red. At the start.
One trait.
What are we writing?
So you need to do
On the peak effect.
That's what I want.
That one you are writing on the peak effect.
yes, and for example, in this case, the environments that don't have information is because at the start we don't have information for that specific environments. Okay.
For me, I can do my
Oh, okay. That one we should give it a name.
So we have another option here for assign different distribution in the model. In this case, all our variables are normal distribution. But in the case that, for example, we have a variable with counts, which distribution will need to select Poisson. So we have an options for change the distribution depend of the variable that we will analyze. But in our case, all are not.
What about if it is a percentage?
Sorry, where did you get
Percentage.
Excuse me?
Here do you find it? Oh, here.
Here. You need to go here and discover here. Okay?
So this gray leaf spot is a score, which is a count.
Yes, but in this case, we can see that maybe
GR.
this one, right?
Yes, yes.
It's an score.
Yes, it's a
So,
score.
yes. Maybe here we can
They are just observing environment.
we have only 3 environments, so we can decide to trade at the same like the others.
So an example of a score is does it have to be count or score? Score will also be considered as count.
In this case, it's because your score is between 0 and
Yes.
5, right?
Yes.
So maybe we can treat this variable like a multinomial because we can put it in different
Yes.
in different categories.
Okay, so if I have a score like present or absent, just 2, 0 and 1, I'll go to this Poisson. Okay, I'll go to binomial.
But also, if you have a score of 0 and 1, it's not really a quantitative trait.
Yes.
Yes.
So you wouldn't put it in the selection index. You treat it separately as a qualitative trait.
Okay, so I'm just looking at a situation where you need to use this alternative response distribution. What situation do you imagine?
No, not for apply in all the analysis, but for example, only for do the single trial,
Yes.
and so the behavior is useful or for multi-environment. But when you try to put it in selection index, is not recommended.
So for selection index by default is normal distribution.
It's a quantitative traits.
Okay.
The selection index is really only for quantitative traits.
Okay.
Now, if you have something that's on a 0 to 9 scale, we're kind of approximating it as a quantitative trait, but it's an assumption because it's obviously not completely. It's a distribution with only a limited number.
Oh, that means you cannot use grain, yield, and the root lodging in selection.
No, you can. You're using they're both quantitative traits.
Oh, but it is a scale 1 to 9.
With the 1 to 9, we
Percentage.
if it's 1 to 9, in general we would use it, but we're making an assumption that it's roughly quantitative.
But do you have to transform it or just the 1 to 9?
Well, the thing about the 1 to 9 is usually if it's a disease score,
Yes.
1 to 9 is not linear. We've got fine differentiation at the lower levels. You go from 0.01 to 0.1 to 1, and then you go 10, 50, 100 or something like that. So it's not linear. And if you translated that back into the percentage, then you would probably transform it with a log transform. When you transform it with a log transform, you usually find out that the scale that was created roughly is actually a log. The scale is more or less a log transform because.
So you don't need to.
So in general, you could make it a percentage and log transform it, but often that's very similar to the original scale.
Yes.
Because a lot of those disease scales are effectively a log scale because you're separating things at the lower level, 0.1,
Yes.
1, Well, you're usually going like, 0.001, 0.01, 0.05, 0.1, 0.5, 1, 2, 5, 10, 15.
So you're better off leaving it as it is.
Depending on the trait, yes. Sometimes you are, but you're making an assumption about approximating a normal distribution.
Disease and before can go.
It can go.
It can speak as normal.
We could have
the incidence as percentage. Lodging is quite percent.
Give a definition.
It could be an option for lodging.
This means this, so that means there's a gradient.
But I think when you looked at the stem lodging, it was, I don't remember what it is.
No, yeah.
Okay. Then in peak effects,
But for now we'll do the exercise without this one.
Don't worry, it's okay.
in the peak effects, you will see the summary information about your location. Okay. So here we can see how many hybrids, how many mothers and fathers have for each one of location and hybrids, and how many replications and blocks, and how many rows and columns we have for each one of the environments. So all of this is for be sure that the information that we upload is correct, because we suppose that we know the information. Okay.
Where can we get this summary?
Where did you get this?
Yeah.
Here in peak effects,
And you click.
and click here. Okay.
The error.
Don't do like me.
It's right here. It's right here.
No,
You don't arrive.
No, I arrived.
We can
But
live with
I
the error.
finished something that you didn't.
Someone started early, and then and then got tired and dropped off the race.
I went my head in the mouth.
Because it's online, right?
I did it.
Yes.
I mean, the execution
That's a feedback.
cancel everything wrong again.
But no,
I was
But
catching up.
fortunately, you can go back again and
Go back
visualize.
and start. No, seriously.
I went back and visualized.
Meaning
Even I have run it. I went back and.
The offline. You want the
The offline is freezing now.
Because you didn't enter sense. Yeah.
No, it's tired.
It's like a
It's tired.
Anyone see an arrow? Same arrow, no rules to aggregate.
Yeah, I've seen that. I thought that is my. No, I've seen it. You are not alone.
You got the error as well.
Yes.
Yeah, you are not alone.
But she is not getting it. You are not getting it. No, he is not getting it. He's only
Getting someone.
This one is perfect.
Los que
Ah,
están
okay.
online es donde le sale la.
even the summary does not
Maybe
present
because of the fact we
the lower.
have you run it?
Cannot see the designation.
Yeah, I run. No, I didn't run.
Okay.
Yes,
Yeah,
because
I think that's my problem, but it's not the.
Yes, I'm offline.
No, so the error.
here is location. Location. Yes.
No row to aggregate.
Yeah, no rule to aggregate. I'm also seeing.
Because you don't know the mother and father.
Even here. I can't see.
Then that is not error. What do you want to aggregate then? There is nothing to aggregate. And we can, I cannot see even the different things together. I need to bring. Okay. Yeah, even that. Okay, like this. I can see only one. Unless I go to.
It's because you don't.
Let me make it. Page, but they cannot be displayed. More even than that. That's the problem. We are in trouble. We cannot see everything.
Didn't know I'll ask you about it.
Designation is hybrid.
It's the same.
Source to normalize irrigation.
Show everybody how it fits.
So source to underline the
For the death rate.
Show everybody. Yes, I'm talking. And then if you show everybody, then we'll take.
Okay.
Right.
Okay.
Guys,
Yeah.
put attention, please. If you don't have these two tables, it's because maybe you miss or forget to upload pedigree information, or because you lost column and row information, or because you are working online. The version online have many issues, so maybe appear an error here. But if you have an error here and you are working offline, the reason is because you don't add the information of pedigree, or you don't add the information of row and column at the start. If this happens, you need to go at the start to upload data and be sure that you select all the variables that we select at the start, because in other way, we will have problems with this follow steps.
Yeah. So that we need to restart new or
yes.
Okay. Close this and restart.
Can you help me the parameters we are analyzing?
Okay. The parameters again.
The traits. You pick
We keep
traits.
that one there. The form, the 3 point. Yeah.
Okay, the parameters that we select at the start was in location, environment, in trial, in rep, in iBlock, BL key, in row, long row,
That's the problem.
in call, range, in designation, hybrid, and in trade, we select the 8 traits.
Yeah.
All the traits that the data have.
I put row.
Okay.
I put a range on the long column.
But no problem. Only you change the dimension.
And then that's big is
Okay.
But what happens?
So everything is fine until here. You can go to define environment. And when you define environments, appear location and trial, and you need to compute and check the status again. And for the pedigree, it's the same. You need to select in designation, hybrid, in mother, parent 1, and in father, parent 2. Be sure that both information are uploaded, because in other way, in the next step, the information is not able to use. Okay?
So,
yeah, we didn't take the And 3 times.
Yeah, it was open because
I took and 3 times.
Excuse me?
And
yeah,
3 times.
You can put it from here.
Okay, yeah. But what is the problem then? Because, okay, recalculate.
I have only one stamp. So I have only one stamp. Is that because I run all the QC together?
Yes, maybe. That's
Then what was the fourth three?
Okay, give me a time for coffee break. Okay. And for fix some of your details.
which ones were what tricks?
Here everything is fine.
When used
Here everything is
just shoot it.
Moisture.
Not moist.
Moisture is moisture is pH. This one, this one, this one.
You're going to with 9 inch.
Objective save you got a trash.
What about this one?
Just a
Okay.
There are certificates.
Yes.
Every time I do a course, I forget certificates and end up emailing Guichet with like half an hour left. This time we are.
So the
Then here, I've done for 4.
yes. By three is okay.
Yes, I've named.
Tag outlets.
I tagged already. They came. And then it's coming back.
Gigi Bible is saying it came and
Only because maybe
Yeah, Inga Banda. Email
They came. Information, what. Then it goes back.
The three trays.
I think says I can't go.
So we can take the coffee break now. We take coffee now. I'm going to come back in 10 minutes.
I start again.
There's no
Go and take coffee.
The second set was what about
The three trays.
features of this one.
I didn't.
Yes.
What was the three trays?
Okay, let me start with there was value, and then the other one. TWT, the other one. For the 4 ones.
The first tray. They will have the that one. Yes. Yeah.
Gigi by graph production.
Yeah.
Where?
The graph, and then check the validity. This is the grain area, that's fine. Here, see the next one you have selected. This one. It is okay. It's part of that one. Look, see here. No, it's not bad. This one. Yeah, this is okay. Then the other one. There are 4 two. That's one. That's one of these two. Then you and the DH. Yeah, they are the 4. You learn.
Genetically, realize dulu.
Okay, it will come from input. Yes. Then select the three trade now. I don't remember.
Moisture content.
Moisture is standard one.
Yeah.
ESL and TW. The 3 trades are those 3 PRL, ESL, and
No.
is part of the 3.
Yes. Moisture
Which one is not part? If there are 3, is a standalone. Okay. Okay.
This one, the coefficient of variation.
It was increased up
164.2.
My goodness.
Run
164.2. But it's not solving the problem. Only moisture is soft.
GYG.
Signing to come later.
And you call it citrates. Yeah, Italian. Then go back again input. Set rate. Now it is TW.
TW, didn't you say together on that time? I think we said.
No,
Huh?
no, it was.
This one is 2.2.
We increase up to
2.2. It was 2.2.
2.2 is more. TWT.
Last
I don't remember.
It was 2.2. I was checking.
I
What I was not
I
doing.
don't think that was our problem. Because I don't remember. If you select that one, they still have a player. For the TWP,
What
the
was
trace,
the
what
coefficient?
trace of the coefficient? The trace
2.7.
2.7. Cannot get 2.7.
Yeah, it's 3.2.
Huh?
It was 2.2.
TWT. We have increased the coefficient up to
around 242. No. TW 3. TWT 3.
And this thing was there because my company, you will, even if goal is corrupt.
No, what is the purpose of separating them? Because we cannot keep it at 3. We want this to go. Yeah,
When you add the value of the QC,
yeah,
it will absorb and consider access and the data looks low.
yeah,
Normal.
that's what we did, isn't it?
So it's just what?
I am at 7. I still have 2.
But we the value of PWQC where I think 200%.
Yeah.
200 something?
Yeah. Let's say add the look. For example, for moisture compression,
Yes.
put around 164 or something.
Yeah.
When she put the QC 164, it looks like the green like crown. At the same time for
TWT was a standalone. Standalone. If we increase only to 8.2, we absorb almost the 9.2. We don't see any radical.
Jamara single 200
200.
It's not so.
I want you that is writing. This is not causing the error. Well, 9.2. The running at 9.2.
Descargué el de Reading, pero bueno, y se descargó el portable de tu Git.
Sí, porque este no sirve.
Okay.
Porfis.
Perfect.
Yeah, around it. No. I will see
And
what I'm
analysis
problem. This infinite the single.
single side.
Single around this. Input. I have the 4 trade, 3 trade, 1 trade. Okay.
Oh, I have 4 sheets.
That's why the problem is.
Suddenly.
This one, yeah, I did. Yeah.
4 trade, 3 trade, 1 trade. You have 4 trade.
Yeah, I think I put them.
Yeah. Remove one
How
from
to
the
remove?
remove one
How
from
to remove
the
one?
list. One.
Bulan sabatin harga juga bukan bisa jadi
Your trade also. Are they all there?
1, 2, 3, 4, 5. Yeah.
Okay. Then okay. Then some on peak effect. That's peak effects. Check if you have 2 pages. You are good to go now. That's what I think the first time. It's I went and restart everything because I thought that the problem was either on the column or.
Me, I
Have you?
Yeah,
Have you?
I corrected.
What about the PC grade?
Maybe they
Maybe you forgot the PT. Can I yeah.
But if I go just straight here to freeze.
Yeah.
Be sure that until here everything is fine. Okay, it's important to see this table about mother and father information because we need to include in the genetic evaluation units. Okay,
I thought okay. This
No,
is
that's before the
No. Finish the process.
It's
of
okay.
It's
okay. I do like this.
Yeah, you will do it then.
No, I'll not.
You will do it.
No, it's already there. You see.
You see that there was a problem. Maybe.
No.
Okay, let's go.
That's one of
Bioflow have so many type of
Data is already there. This one was okay.
Yeah, different sources.
Okay, check to let's see. Also possible. Okay,
A little complex installation.
We're keeping. Okay, okay, that's okay. Yeah, to select only the four. That's you are right. Then you need to remove this one. Yeah, click on this. Delete.
The logic plus.
Moisture is there. Moisture is part of the portrait. One,
This one.
three, and four. No, one,
This one I
two.
think.
Yeah. You remove that one. Moisture. Yeah. Okay, good one. Moisture is part of the treatment. That's what that one. Yeah. Okay.
Like a
No, don't. Anytime you four. Yeah. Four. Portrait.
So that's where we are now.
Okay, then tag.
I couldn't think that together.
Yeah. Good. And yeah. Yeah.
Now yes.
This, and moisture.
Yes.
That one, and moisture.
Pero ahí va.
Yes, one.
62.
Which one's 62?
Yeah, 164.4.
Es la portable, ¿verdad? Porque tienes dos. Bioflow solo y lo portable.
It's 9.2.
9.2. One freeze light,
Okay. What else in the same environment?
That's fine. Because I was funded away.
But the certificate sounds
For the standard.
You know, pictures. Everything. What else? What else?
Okay, you can check them. The way you were selecting the system is totally with the.
So if everything is fine until here, right? In genetic evaluation, select designation mother and father, please.
This is on peak effect.
Yes, in peak effect, we can see these two tables, and here we can add the genetic evaluation units. So we can add males and females for models for progeny testing, like GCA. So for that reason, we will add mother and father.
Yes.
Okay?
To get the GCA.
This
To
one.
get the
This
GCA.
from SEO. Okay, good.
Yes.
Great.
This option run the line by tester
Line
model.
by tester model.
Okay?
Yeah.
This is the problem.
And go to run analysis.
I don't think if
What is that?
Okay, single triangle.
we try not
And running.
simple.
For renaming, but it doesn't show me.
Yes, because this is the
Yeah.
yes, that I share another portable Bioflow. So that one is the new one.
The one I now he
Yes.
downloaded from.
Yes.
Mine is squeezed totally. What's no, it's not online.
Genetic evaluation is
It's fake.
It's fake.
Yes.
If you've got it on your computer, go offline.
Yes, it's not working.
Yeah, this is the problem.
Just
I finished running the laptop once. Sleep. When I came back, it's
Yes, it's not working. Yes.
okay.
That is difficult.
Go offline.
Brain out. Are you there?
That's why I first.
Okay, good.
You did pick it right?
I did.
There is another standalone version, or this is the good one? The email is sent. Okay. Otherwise,
This is for single.
Yes. How far are we?
that is not
You start?
because it's free. It's like
Like mine.
yes,
Oh my goodness.
yeah. That's
So I should start again mine.
no.
Yes, because
Yeah. Exactly. You
No
still
one's-
the error. Go step by step.
No one's just get-
Yeah, that's what the error. Go step by step. Don't put the two together. Okay. Finish one before you go.
Question aspects. When you run okay.
The last one it was working well.
Duro gente davanti
Was low.
Quale problema sta provando? Problema con il
Okay.
One trade.
No.
One trade. All the trades.
It's a single triangle.
Or all the picked name.
Yes.
Okay.
So when finish, you can see the dashboard.
What's it?
Okay. So the first result in the dashboard is a summary. The summary foresee which variables and which environments are available and the number of designation of each one. Okay, so it's only a summary of our information. Okay. And here start the summary of statistics. The statistics that we can see here is the heritability, the coefficient of variance, the reliability, the variance component of designation, the variance component of a row and column, the replication, and the block, the spatial, the residual, and the same, but now for mother, and then for the father. Okay? Why? Because here we include not only designation, we include mother and father in the analysis. Okay? So
online when not specified.
is the field view is again only for see each of the traits in a heat map visualization. Okay, so we can see, for example, here the plant height, the plant height, the values is between 160 and 320, and we can see the behavior in each one of the environments. Okay. And this table we can see graphically here. Okay, so for this specifically trait that is grain yield, we can see the component of variant for designation, for father and mother in each one of the environments. Each column or each bar is for each environment, and each color inside of this bar is the percent of variance. In this case, for example, is the genetic, the residual, and the raw bar. Okay. For example, this one is for column, the green one is for block. Okay, so this is 100 of variance and divided the percent of variant that is for each of the source that we include in the model. Okay, so in all of them, the genetic variation is more than the, for example, the residual or the row or the rep of the column. Okay, and this one is for each of the genetic sources that we include: designation, father, and mother. And then here we will see the other statistics in the summary table. For example, the heritability for each environment in each trait. So look at, this is very important because that we assume at the start here the heritability for this specific variable, that we don't have many variants or a lot of variants. We don't have heritability here. Okay, so the others missing spaces is because remember that we have in many of the traits only 3 or 6 environment, not the all. Yes. So for that reason doesn't appear, but in the others we can see high editabilities, okay? Well, maybe here not. And I think that's it. Okay, so this is helpful for, again, start to take decisions or follow to take decisions, because when we, the decision about this variable is to keep out to the analysis, okay? When we go to do the multi-trial analysis. Okay. And for example, this environment with low editability also is a good idea to delete, to remove. Okay. And you can change all the parameters for C one by one. Okay. If you see here, you have different options for save this specifically graph, or for do a zoom, or for select one part of these graphics, for save it specifically in the case that we need specifically this graphic for my report. But in other way, you can download the complete dashboard, and then you can save whenever you want the other things. Okay?
Yeah. If you download the complete dashboard, it will bring all these separately. You can, from there, you can also copy them. Yeah.
Yes. Yes, it's also available.
Is it difficult to specifically select the data from the PDF, from the download?
From the dashboard.
When we download from the dashboard, we'll get the PDF file.
No, it's not a PDF file. It's a HTML file.
Oh, okay. Then we can select and copy paste each separate data.
Yes, it's totally interactive like this.
Yes, it will work like this.
It's exactly the same, but in your computer, not in the Bioflow. Okay? But it's exactly the same. You can change, you can interactive inside of the file.
What I'm saying, if we need a specific plot, for instance, to copy that specific plot,
yes, you can do it.
It's possible, yeah.
Yes. Yes. This table is for the modeling parameters. So here we can see for each trait and each environment, the model that at the end we run. Okay? So for example, for grain yield in this environment, in the fixed part, we put designation because we select to obtain the blues, sorry. If we select to obtain the blobs, so designation is in the random part, okay? But in this case, we select to calculate the blues. For that reason, designation is in the fixed part. In the random part, also only row will be there. And the terms that we remove to the model because we have variant 0 is column, replication, block, and the spatial test. Okay, the family that is normal. Here is the designation type is blue because we calculate blue. And then the same for mother and then the same for father. Okay, let me show you the others. Okay, if you see, now is the model for mother here, and down is the model for father. And then for the other environment, and then for the other environment. So all the information about what model we use for each one of the traits and which and for each one of the environment is there. All the information is there. Okay. Now, the blues in each designation, in each environment, we can see the blues for each one of the traits. Okay. And here we can see the behavior of the blues for each one of the traits in each one of the environments. Okay, so here we can change or see the
trait.
Yes. And here we can see the blues for each one of the trait in each environment, but in order to see the top designations. Okay, so this is the order. The first one designation that we can see in our results, but specifically for this environment. And we can see divided by father, mother, and hybrid. Okay. This appears like this because remember, we add father and mother to the model. If we only assign hybrid, the only one that appears is this one.
Okay.
Okay. So in the case that you have results only with this one is because you don't include mother and father. And the same for the colors of here. The green one correspond to the father. The orange one correspond to the hybrid, and the blue one is for mother. Okay.
Father, blue.
Right.
Here is the labels.
The mother blue, the father.
Green is father,
Yeah.
blue is mother, and the red one, well, orange one is for the hybrids.
Mine is different from you.
Yes. Why?
Have you selected the same trait?
Just selected the hybrid.
Because you include the entry line. It's fine. Only include one more code because you include checks and lines. So constellation is for.
It's only selected hybrid.
You can find the correlation between environments.
Remember, these are
Okay? So for each trait, you can see the correlation between environments. So if you see orange one, the correlation is low. If you see green one, the correlation is high. And that's it. Because in the next tabs, you will find the same information that we saw, the prediction, the metrics, and the modeling. Okay. For that reason, if you download the complete dashboard, you obtain all the information.
Yeah, I mean, there is also previous lectures having that pedigree information. May not be important to use the black instead of the blue to increase the prediction because we have pedigree information that may give us more prediction accuracy.
Yeah,
But something. Okay, yeah.
But here is in the single trial analysis.
Okay. We may use it for the.
Yes, for multi. Okay. Okay, until here, everything is clear. So the next step is go to do the multi-trial analysis. Okay, so go to the input steps and select the single trial analysis that you did before. So here you can see we have the QC data modules and the single trial analysis modules. Okay. Then go to P-tray. So remember, here we will pick the traits that we include in the selection index. So we decide before that PRL will be out of the analysis. Why?
Outliers and the data quality.
Yes. So we can see here again. Okay, because we don't have enough information for included in the analysis. So here in the traits to analyze, we will pick all except the PRL. Okay, so now we will work with only 7 traits, not 8.
Why PRL?
7.
Because of
Maybe we need to say 3 or 2.
Four quality basis, man.
Yeah, that's the way I said it.
Yeah. Oh, there's another place to read about
Dashboard.
Now, for pick the model, remember that in the first class that I explained this model of some of you, not all of you, I told you that if you go near to each one of the model, a description appears. Okay, so if you don't know what is main effect, you can obtain a description of what is the goal for this model. So in this occasion, we will run a compound symmetry, because in compound symmetry model, we include the G by E interaction in the main effect. No. So for that reason, we will use compound symmetry for run this analysis. Okay? Now, we need to include the fixed effect, the random effect, and the covariance of random effect. So, for a fixed effect, we will put environment. For random, we will put designation and the interaction between environment by designation. And in the case that we have genetic information or weather information, we can include this covariance to this specific random effect. But it's not our case because we don't have weather and we don't have genetic information.
Which one is weather? Which one is?
Here, when you have weather information, here appear an option weather here. Okay, appear here an option of weather. Okay, in other case, you can select the other one for market information or the pedigree. But in this case, we will use the simple model. Okay.
What about if we pick pedigree because we have pedigree?
We can include in the designation covariance for the designation, but in this occasion, no. For the example only. Okay. Okay, so we will keep the file values that appear in this part. And this part is very important. Why? Because here, for each trait, we can visualize what type of information we have at this step. So we have 315 rows of the phenotypic information, the same for the pedigree information. So this is important to know because we need to be sure that all the information that I upload is available for our analysis. Okay? Then the connectivity between environments. Okay? So for the trait pH, the connectivity of designation of each environment is here. So again, see the scales of the connectivity for know which environments have less hybrids than the others. For example, in the case of this one, remember that we don't have all the information able for all the environments, so we can see that we have few environments, but the connectivity of them is looks like this. Also, you can see again the genotypic correlations between environments. So in many of the environments for pH, the correlation is almost or is 0, and in many of the others is negative. Okay. And this one is the sparsity between environments. So you can see here all the environments that we are able in the database, genotypes, sorry, and here the environments. And we can see the sparsity of the information for all of the traits. Okay, so we can see here in which environments we have which genotypes. Okay. And then this option is in the case that we run the other models, the other models. So we can change here. Also is useful in the case that we want to delete or remove one of the environments, like you mentioned at the start. We can do it here. Yes, for delete the environments that we want to delete for each one of the traits. You only need to change one by 0. For example, in this case, if we want to delete this environment for grain yield, we only need to change to 0. And also we have a threshold for heritability, reliability, and the mean for environments. This threshold taking account for a drop to the analysis. I mean, for example, if one of the environment have less heritability than 0.1, this environment is automatically deleted. Okay? Or
Just that value. No?
yes,
And adjust that value.
yes, you can adjust, you can change all the values depend of your decisions. Okay. And again, you can see here the distribution, but in our case, we keep normal. Go to run analysis, change the name, and run. Okay, guys, so in the dashboard, you again have a metrics table. And in this metrics table, did you remember that we can see all the statistics like reliability, variance, component variance for each one of the random parts, the standard deviation, and things like this for each one of the traits in each environment. Okay. And also we can see the prediction for each trait in different in each one of the environments. So also here you can see trait by trait the behavior across all. You can see again the connectivity between environments. So how many genotypes in common we have for each one of the traits?
Can you explain?
Because we don't have hybrids and
The connectivity is the genotypes that are in common in each one of the environments. For example, for these two specific environments, for environment 1 trial A and environment 6 trial C, we have 34 genotypes in common.
Selected, you mean, or?
No, in the data.
Planted, okay.
Yes.
Okay, okay, yeah.
You see.
Load the analysis again. What did you see?
And then again, you can see the correlation between environments in each trait. Okay, but remember that this information is now for across. Yes, exactly. And the biplot that you tell me that.
Yeah, this is a biplot, but I want to change this biplot to the which genotype win at which environment.
How?
Which one genotype?
Which one
wins at which environment?
You want
the
polygon.
Yeah, polygon.
Yeah, not the biplot, because this one is a biplot, but the polygon is inside of the biplot. So we only need to add an option for add that polygon, and yes, maybe we'll do it.
We have an option.
No, right now, no. Right now is only the biplot. It's able only for see the biplot. Okay.
we need to add that on.
Okay.
The final.
Now for magic.
But here you can see the entries or the genotypes that the behavior is better across all the environments for each of the traits. Okay. So again, you can see the father, mother, and hybrids. the prediction table for each one of the designation in each one of the environments. And also you can find in this table the across all, the designation across all the environment. So you can find conditional and marginal values. Okay, because remember that we are using genotype by environment interaction.
So on that, if we want to this this output for application, it has no any labels for each genotypes.
Here?
No. On the mean value, or the mean value of each genotype. Yeah.
Here?
Yeah. How we can see the labels of each genotypes.
Well, this graphic is for your information. In the case that you need to redo, because I mean, it's not possible to add labels here because looks bad. So only in the case that we put less information in the graph, we can see labels. So if you want to redo this plot, you can do with the prediction information because we are ordering only the values, the predict values.
This is used for visualizing the genotype above check, below check.
Yes.
Excellent.
Yes. And you can see here the predictions, so that I mean you can find the conditional and marginal. And also the correlation between traits. Okay, so this is also very important to see for know the correlation between traits across all the environment. Okay, so all of this information is now across environment. Okay. At the end, we can see again the modeling parameters for each one of the traits across environments. Okay. So at the end, we use that model for run this analysis. So again, in the other tabs, you can find the same information that we saw in the dashboard. So now we are ready for go to selection index. Okay, that is the next step. Okay.
I don't follow that one. Later on,
Just a moment.
let's index.
We go where?
Okay, for the selection index.
For it. This one.
In the next.
Same treatment.
Remember that all have an order. First of all, we need to upload the information in that tab and do the quality control. Then in selection, we will find single trial analysis, multi-trial analysis, and selection index. Okay, in fact, is in the order, okay? So with the results of multi-trial analysis, now we are able to do a selection index. Okay, so we need to pick the traits.
All the traits.
Yes, pick all the traits. Okay, and if you can see here, a plot, this plot represents the breeding population means and the desired population. So at this point, my desired population is the same like the breeding population means. For that reason, we only saw the green color. Okay? But if we go down, we can see here the information for each one of the traits. And here we have the option for put the target values. Remember the class of Tuesday? No, Tuesday, Wednesday? Tuesday. Remember that class of the selection index? When kids talk about the target values. So here in the original scale, you can select to increase or decrease the plant height in this with these values.
Based on what's exactly.
Yes, maybe the higher value that we can increase plant height in this occasion is 90 or almost 20 centimeters.
These values are constrained by the variation in your population.
Okay.
By the genetic variance in the population.
Okay, good.
Yes.
So where you are now is the green, but also you have a constraint in how many standard deviations you can move given how much variance you have.
Okay.
And that's included in there.
Okay.
Yes. So if you start to decide if we want to increase or decrease the values for each one of the traits, we can change the scales. For example, if I change this scale, well, if you see, it's very lightly, but we can see a difference between these 2 points. Okay? So, for example, if we want to decrease this one and increase this one and decrease this one and decrease this one. So now my desired population is very different to the mean values that we have. Okay? So this is interpretation of this graph. The orange one is the values that I have in my population in that moment. The green one is the values that I want to increase or decrease. It's my target population. It's clear?
The green one represented the data, my real data, or which one?
No. The orange.
The green one was the same because the values were set to be identical. So the green was on top of the orange before. So when you started the default, remember everything was down the middle.
Yeah.
So the default at the start is where you are now is where you want to be. And you have to change where you want to be.
Okay.
So the green was on top of the orange exactly before. So the green is, so actually I think I said, I'm correcting it because I'm the one who made the mistake in how I said it. The green is where you want to be. The orange is where you are. But when the first graph comes up, they're the same, but the green is on top of you. Does that make sense? So this figure here, if you took the green away, there would be an orange underneath.
When you start to change the target values, the green one start to move.
Yeah.
Okay?
But where you are at the moment is exactly under that green one. There's an orange one underneath it.
Yeah. So when I change this desired value, I depend on my information.
Yeah. If you set those values, you could. And the easiest thing is just to set those values to what your targets are in your target model. So if your target is less than 1.2 on the disease, then you put that 1.2 as the target of the disease.
There's one.
If the target is yield 5% of check, so you work out what the check is and you add 5% and you put 5%.
It's not possible to see.
Yeah, because I came on this one. This is just an analysis. So, yes. Yes, I am. What? One place. What is here? Oh, madam. And father. I was yes, you can make yes, and father, you get mother and son.
So if you start
Yeah, I think it's here, yeah.
to move these parameters, the graphic in automatically starts to be different between the green one and the orange one. So for example, I try to increase and decrease these variables like this, for example. So did you remember the table at the start that have signs and values? So that table represent the values that I put here. Plus for TWT, plus for grain yield, minus for PSL, for SRFN, and for GLS. And I keep the same for plant height and keep the same for moisture. Okay? If I put these target values, my desired population must look like this, like the green one. Yes? So this is my target population. We try to increase and decrease depending on the values. Okay? And here.
Is that color? Green, orange, and
Excuse me?
the color, like the implication of the color.
Here. Green
these are populations.
is the my target population, the population that I want to obtain. And the orange one is the population that I have in this moment with this data. It's fine?
Does everyone understand what you mean? The population we have at the moment is the mean of the population in the trial. So you're going to make a selection decision to move that mean for every trait. And when you make that decision, you're moving from where you are in the orange to where you are in the green. So if you're this is where your population currently, the current level of your disease here, and you want to move it to here, to this point, which is your target. And same here, you want to go from the disease level here, you want to move in to there.
For yield?
Yield, you're trying to go from
here to there.
To go upwards because you want it bigger.
Clear or not?
So this is like when we just do the basic reader's equation, you've got a normal distribution and you're trying to move that to one side. You're trying to move that along. This is that, but in 7 dimensions because you're trying to move the population in 7 dimensions. And it's just showing the mean where you are and the mean where you want to go to. But it's scaled so that all traits are the same.
Yes. Okay.
I was sorry.
That's too much.
I was like let me say
okay. We can achieve that because this is the level they can achieve in the population. You can push it to
the desired rate I want is like, let me say 1.5 or 2. I put those things on 1.5.
Yes.
But in this case, you use the value.
No, I use
Why don't we use actual value?
I want to keep the same value for plant height. For that reason, I put it in the same point, 0. I wanted to increase. I don't want to decrease. Keep the same value for plant oil. For that reason, I don't move. And also for moisture. That is the explanation.
I think you don't need any improvement for plant health.
No, you're trying to keep it stable.
You want stable.
So, I mean, take it like it's a breeder decision, what he desires to achieve. So it is your decision, but now this is the demo, take it or the demo.
Yes.
No, as a breeder, no. When you look at this index, you can say that I want to move the head to this direction, to negative, to decrease, increases the breeder's decision.
Yeah, but here for plant I want to be reduced.
Then you would move it to the left.
Yeah,
then you move it to the left.
Otherwise, I have to know the correlation of the traits here, not in the breeding, because I'm selecting my plant type reduce, my disease reduce, my yield increase. So that
So what I'm saying is that you have the flexibility to move it in any direction depending
No, I'm saying not about direction. I'm saying why didn't we use actual value 1 to 9 for yield 1 to maybe 13 tons or 15 tons?
It's just a way of visualizing it of whether you're going plus or minus away from the center. You have to, you're correct. To do this, you need to know the actual number and where you are, and then
because I know the range.
Okay.
I know the height of maize, for example. I will not go like 400 centimeters.
This is a presentation issue. We present it.
It is a kind of standardized value that we use to make the index, or it's not that if it is not the actual value.
This is the actual value. It's the original scale.
Okay.
If you want to use an scale value, you need to move here to true.
Okay.
Then now.
And now the direction that you need to move is in a standard deviation.
Yes.
So increase 1 standard deviation, 2 standard deviation until 5 standard deviation. Okay.
But
So
the point
you
is on the right. The figure is always scaled because you can't have all the. You can't have 0 to 1 on the same scale as
You see, the
2 to
problem
1.
is if you want to
But
reduce,
this one will be more representative.
you don't have that option to increase. That's the
But it
problem.
all depends on you. You know that
The picture is
Standard deviation.
This option that
We
you
use
use
standard
just to decrease it.
But my
That's the
question,
problem.
the diagram is standardized to a mean of 0 standard deviation.
Yeah.
Okay.
Yes, it's just because you can't look at some. They're all on different scales. You can't put them in the same diagram.
Now also you can see the response to selection depend of select of portion that you select here. In this case, we select 10% of the individuals. So do you remember that we have 211? So we will select only 21 more or less individuals. With these 21 individuals, our distribution for each one of the traits looks like in blue. Because remember that the orange one is the whole population. Okay? So if you change the proportion of selected, well, obviously the distribution change. Okay? Okay. But in our case, well, maybe take 20% the individuals. Okay? And you can also see the other parameters that we calculate before in the multi-trial analysis. Only in the case that you don't remember these numbers, you can show it in these plots. Okay. And then when we are sure that this is my target values, you only need to go to run the analysis. And here, you will see the designation, the values that we have for each of the traits, and the merit or the selection index. Okay.
Each 1%.
So here is in order to see the better one, hybrid selected by the selection index. Okay. So in this case, for example, we have the grain yield higher. That is my goal. Also, my goal is higher in TWT, but is less in this, and this. Okay, so my index need to select the smaller values in these three traits. Okay, for example, in this case, we have not a higher value, but is high. But for example, in GLS is not the smaller one. We have another smaller one, but the grain yield is smaller than this one. So if you see, the index try to combine all the environments, all the traits, and try to develop an algorithm, a goal for select the better one. And again, you can see here the same plot that we saw in the step before. The same plots that we saw in the step before with the selected proportion. And here we can see the selection index versus each trait. So how is the behavior between this trait and selection index? So also, again, we can see the mother and father and hybrid information divided in three again. Maybe here is a good idea to put in different colors also.
Yes.
For see better. And in the last one part, we can see the behavior for each one of the parents. For the parent one and for the parent two. This is the behavior for each one of them. And at the end, we have the overall behavior. This is across all parents one, and this is across all parent two.
What is that?
Everybody's following. Is everybody following here?
No. Yeah.
What you're gonna select on is the parents, not
Yeah, it's not the hybrid.
So these are the estimates for the parent.
Okay. Okay. Parent one, parent two. Okay.
Yes, this is parent one.
Okay.
This is parent two.
Okay.
Could you go back up to the?
Yes.
Right up to the top. First picture. Does everybody understand what we're looking at here now? So what we did before, we had, this is where our population is. This is ideally where we'd like to get to.
Yeah.
But because we have all these correlations and you know, we have a covariance matrix of traits, they have different heritabilities, they have different correlations. What we're now looking at is, this is now the reality, not what, this is what we've achieved, not, isn't it?
Now,
But
this
still
one
not.
is the same. Is
It's
exactly
the same one. Oh,
one.
okay.
Yes. Everything is clear until here?
No.
Yes? Okay. So now with this index selection, we can go to the main optimization. Okay? Remember this formula?
Yeah.
Yes? This formula is using for do the optimal cross selection here. So we need to select the index version to analyze. So the before that we did. Here in trace to optimize is the desired index. The effect type to use here is designation. And then the important parameters, the most important parameters that we need to decide. The number of crosses. The number of crosses depend on what?
Number of parents,
Line and tester.
Not necessarily, maybe depend of our goal, how many crosses we will plant, if we have enough money for plant all. Yes?
Yeah, maybe, in the breeding program, you already have a number of crosses you can handle. You know that one, maybe 40 crosses, 60 crosses you are doing.
Yes. Yes.
That.
Yes. And remember that the target angle depends on what? If I don't remember, I can go to the help and see. A zero value is equivalent to graded weight to performance and long weight to genetic variance. A 90 degrees represent the opposite. If I don't remember what the parameters tell us, or we need we can go to the okay for each one.
Okay.
So let me put it 20 in the number of crosses, and the target angle keep in 30.
What is the minimum of target angle?
Here.
Minimum is zero. Minimum is zero.
You can see the plot here, or you can go to the help and see the description. Okay? All the modules have the description, right? The description here or the description in each one of the parameters. So feel free to go for each one of the parts if you don't understand something, and you can find a description for each one of them. Okay? It's very useful.
Sorry.
Yes.
The entry type used in the optimization, we keep only the parent or everything. I don't know. I've hidden select entries. A little bit. All of them.
Delete and only keep hybrid.
Only hybrid.
And then the relationship that we will use for do this calculation is pedigree, because we only have pedigree information. But in the case that we have genotypic information, we can use genotypic information, or we can use both. Okay? Finally, run.
That contribution, I need to see the.
Yes, 2030. Now you can see the crosses for the best parent.
Yes.
Okay.
So all this one, I should leave it as it is. But I shouldn't change anything.
Okay.
Environment to use intercept. Yes. Environment to use for selection indices.
Desire.
Indices.
Yeah. Click on it.
Guys, there are another things that I want to show you.
Okay.
First of all, when we finish, we need to save our results, right? For be sure that not all my information is lost. Okay? And then when we go to see again the analysis, we can recover the information, the dashboard information in Bioflow also. How? Well, we go to the other functions in analytical modules, and here we can reconstruct each dashboard. For example, in the case that I want to see the multi-trial analysis again, I need to select multi-trial analysis and then pick the stamp that corresponds to this analysis and build dashboard. And if you see here, you can recover all the information again here. Okay? This one is in the case that you, for example, forgot to download the dashboard, but you save all your information. So you can reconstruct the dashboard and save it. Okay? In test of do the analysis again. Okay?
Build dashboard.
Only in the case that you need to do changes in your last analysis, well, you need to redo the analysis. But if the only goal is to recover the dashboard, you can use that module. It's okay?
The last, when we save the last,
Have you saved the last one?
No.
Go on.
do we
Yes, it's
save the all
Yeah.
analysis we did before?
No, it's not.
Yes.
No. What?
Yes, you need
On
to
that
save
function.
all the analysis
Where I am.
in the objects. If you remember that when you save all the information,
Yes.
Where I am.
the format
I said it's where I am.
that you, when you
Click on
save the information is in our object, our data
There.
object. So
All those, yeah.
first of all,
you
you need to
Dashboard.
save this information, and then for recovery this information, you need to upload, and then recovery the dashboard.
build all.
Yes, build dashboard.
Yeah. Yeah. Open it.
And then download.